students, I hope your preparation is going good. If not, don't worry. Sri Gurukula is here to help you. And I am Anmol Yadav. I will be your physics and mathematics mentor. I am an NEET graduate. So bring out your books. Let's make your preparation stress-free. Today I am back with another video on motion in a plane, and today we will be discussing circular motion. So we'll quickly revise all the important formulas and we'll try to solve few PYQ questions as well. So let's start. Circular motion or kinematics of circular motion. In kinematics, we have studied about displacement, velocity and acceleration, correct? We studied about displacement, velocity and acceleration. The same thing we will study in circular motion, but with different name. Displacement will turn into angular change, which is angle theta, velocity to angular velocity, and acceleration to angular acceleration denoted by alpha. So whatever formulas we studied in kinematics, that is velocity is equals to dx by dt, or acceleration is equals to dv by dt, or another formula is v dv by dx. Similarly, we will replace x with theta, velocity with angular velocity, and acceleration with angular acceleration, and we will get our basic formulas for circular motion. So angular acceleration omega will be equals to d theta by dt, and angular acceleration will be equals to d omega by dt, and another formula will be omega d omega by d theta. So this is our basics for circular motion. Now through this, in kinematics, through this we have derived three formulas for constant acceleration. Similarly, we can derive three formulas for when there is a constant angular acceleration. So through this we got three formulas. Those were v is equals to u plus at, and s is equals to ut plus half at square, and v square minus u square is equals to 2as. Similarly, we'll replace with the angular components. So velocity will become angular velocity. Initial velocity will be initial angular velocity denoted by omega naught plus alpha into t. So this is our first formula. Second formula will become, instead of s we'll write theta, correct? And initial velocity is omega naught t plus half alpha t square, correct? Now similarly, this last formula as well, omega square minus omega naught square is equals to 2 alpha theta. So these are the three formulas for circular motion when angular acceleration is constant. Now what is extra in this chapter? What is different in this chapter? So we'll study three extra relations. First we'll study about relation between omega, that is angular acceleration, and speed, which is a tangential speed, correct? Now how we'll derive this? So we know that angular acceleration omega, angular velocity omega is actually d theta by dt. What is this theta? What is this theta? Theta is actually arc divided by radius. What is this arc? If this is a circle and this is the center and this is the angle theta, so this is our arc length and this is our radius r. So this arc length divided by this arc length divided by r will give us this angle theta, correct? So we can replace theta with arc length divided by radius. So omega will become d by dt of arc divided by radius. Now radius for a particular circle will remain constant, so we can take 1 by r outside. So omega will become 1 upon r d by dt of arc. Now very small arc, if we'll see a very small arc, let's see a very small arc. This is a very small arc. So very small arc will be a straight line itself, correct? So very small arc will be like a straight line. So straight line means it is a very small displacement. It is a very small displacement with respect to time. So displacement with respect to time, what it will give? It will give us a velocity. So omega will be equals to v by r, or we can write v is equals to omega r. So this is our first relation that we are supposed to remember, and very important relation. Okay. Now another relation that we will see is relation between angular acceleration alpha and our tangential acceleration at. So if this is the circle, what's the relation between this angular acceleration alpha and this tangential acceleration at? So how we'll get, we know that alpha is equals to d omega by dt, and omega just we proved it is v by r. So alpha is equals to d by dt of v by r, and 1 upon r again for a particular circle radius will remain same. So alpha will become 1 upon r dv by dt. What is dv by dt? It is acceleration, which is our tangential acceleration. So alpha will be equals to 1 upon r, basically at by r, which is tangential acceleration divided by radius, or we can say that tangential acceleration will be equals to alpha into r. So this is another important relation that we are supposed to remember. Now this is the tangential acceleration. Tangential acceleration is responsible for change in the tangential acceleration is responsible for change in speed in the circle. See, in here there will be some speed. If we have some tangential acceleration in the same circle, the speed of the particle will increase. So tangential acceleration is responsible for change in speed. Okay, now there is not only speed is changing. If it is a circular motion, for example, here we have some velocity, correct? Let's see another case. Let's suppose the speed is not changing in the circle. Let's suppose the speed is not changing in the circle. This is our velocity v, correct? But after some time, the same velocity is there but in a different direction. The same velocity is there, the same speed is there, but it is in some different direction. So overall, initially velocity, but see, speed is not changing. What is changing? Velocity is changing. Velocity is speed with direction. So speed is not changing, but direction is changing. So who is responsible for this change in direction? So there is another term known as radial acceleration. Radial acceleration. This is responsible for change in direction. Change in direction. So what is the formula for AR? In your textbooks there will be a proof. There are multiple ways to prove. One is through similar triangle criteria, and another way is to prove through vectors as well. So for now, proof is not important. For us, formula is important, okay? Because we want to solve question in competitive exam. So formula for radial acceleration will be equals to v square by r. This is our tangential speed divided by r will give us our magnitude of radial acceleration. Now, using all these concepts, let's try to solve some questions, PYQ questions. So first question is, a particle starts from rest, moves in a circle of a radius r. So we have a circle of radius r. A particle started from rest means omega naught is equals to 0. Initial angular acceleration, initial angular velocity or initial velocity is 0 of a particle. It attains a velocity of v naught meters per second in the nth round. So after completing n rounds, when it is now it is moving with some v naught velocity. Now what will be the final omega? Omega we know that v by r. So for this case it will be v naught by r, and our radius is small r. So this is our final angular velocity. So we have initial angular velocity, final angular velocity. Its angular acceleration will be. So which formula we should use? See what we have: initial acceleration, initial angular velocity, final angular velocity, and we are supposed to find angular acceleration. Any formula? Yes, we can use omega square minus omega naught square is equals to 2 alpha theta, correct? So final velocity square means v naught square, final velocity square means v naught square by r square, v naught square by r square. Initial velocity is 0 is equals to 2 times alpha we are supposed to find, and theta, what is the angle it has rotated to attain this velocity. To attain this velocity we have rotated n times. So in one circle how much angle we are completing? 2 pi degrees means 360 degrees. So for n rounds we will complete n times 2 pi. So our theta will be n times 2 pi. Correct? Now only unknown is alpha, so from here we can calculate alpha. So alpha will be equals to V naught square divided by 4 n pi r square. V naught divided by 4 n pi r square. Correct? So this is our angular acceleration. Can we see any formula like this? Yes, we have option C. So option C is our correct answer. Now let's see another question. Another question we have, in the given figure A, this A is given as 15 meter per second square, represents the total acceleration of the particle. So this is the total acceleration. What is total acceleration means? In this case we have some tangential acceleration as well, we have some radial acceleration as well. So this A is given, represent the total acceleration of the particle moving in the clockwise direction. So direction of particle also given in a circle of a radius r. So this r is also given as 2.5 meter at a given instant of time. So this is the instant of time, this is the photo at a particular instant. Now the speed of the particle is, at this particular instant, what will be the speed of the particle? This v is unknown. What will be the speed of particle? Now we know that radial acceleration is equals to v square by r. So if we can find radial acceleration, we can find the velocity. So what is radial acceleration? Acceleration which is pointing towards the center. Acceleration which is pointing towards the center. If this is A, let's divide it into components. So if this is A, then this will be A cos 30 degree, and along the tangent there will be A sin 30 degree. So which is our radial acceleration, this or this? This is the tangential acceleration and this is the radial acceleration. So AR is equals to A cos 30 degree. Correct? Now let's calculate this. And AR is also equals to V square by R. So V square by R is equals to A cos 30 degree. Now let's put all the values. The only unknown is V. So V square is equals to acceleration value given in the question, it is 15 and radius given is 2.5. So 15 cos 30 degree is root 3 by 2, and R will multiply here, and R is 2.5 I can write it as 5 by 2. Now how, if we have calculator, we can simply calculate this and the final answer will be 5.7. Final answer will be 5.7 meter per second. This for velocity, V is equals to 5.7 meters per second. This is our final answer. Do we have any option? Yes, C is the correct option. Now without calculator, how we will be able to solve this? Correct? This is the important question. So V is equals to, first of all let's divide this 15. We can write 15 as 3 into 5. So 3 root 3 into 5 divided by 2 into 2. Now let's take root on both the sides. So V is equals to, see, 5 into 5 will become 5 after taking root, and root of 2 into 2 will become 2, and this root of 3 root 3. Important question is how we will calculate this root of 3 root 3. We know that root 3 value. We know root 3 value. Root 3 is equals to 1.73. So root 3 into 3 will become, so let's multiply it by 3. 3 3s are 9, 7 3s are 21, and 3 1s are 3, 4, 5. 5.19. So V is equals to 5 by 2 into root of 5.19. Now 5.19 is between 4 to 9. Is between 4 to 9, which means it is between root of, it is between 2 square to 3 square, means root of this is between 2 to 3. If we'll take root on both the sides, so root of this is between 2 to 3. So something between 2 to 3, if you will multiply here, you will get to your answer. But you can find the exact value, means close value as well. How we'll find the close value? Now I am going to show you an important method to find root of any value. We are supposed to find root of 5.19. How we'll calculate this root? So I am going to show you one method, which is root of any number a will be equals to that number a plus b. What is this b? B is the closest perfect square. Closest perfect square to a divided by 2 root b. So for our case, 5.19, and closest perfect square is 4, between 4 and 9, which is closer. 4 is more closer. So we'll add 4 divided by 2 root b. So 2 root b, b is 4. So root 4 will become 2 again. Now calculate this. This will be your answer for root of 5.19. So this, after adding this will become 9.19 divided by 8. So let's divide 9.19 by 8. 9.19 divided by 8. Not 8 divided by 4. Sorry, it is 2 to the 4. Correct. So divided by 4. So 4 to the 8. 1.19. We'll get point here. So 4 to the 8 again. So here after subtracting, how much we are getting? 3, 9, and 4 9s are 36 and dot dot dot. So 2.29. So this will give us answer 2.29, and 2.29 into 2.5 will give us our final answer. So V is equals to 2.5 into 2.29. Let's do that. 2.29 multiply by 2.5. 9 5s are 45. 5 2s are 10 plus 4 14. 5 2s are 10 plus 1 11. 0. 2 9s are 18. 1 2 2s are 4 plus 1 5. 2 2s are 4. So this is 5, 12, 7 and 5 and 3 decimal points. So 3 decimal points. 5.725. So our final velocity should be 5.725 meters per second, and our correct answer is 5.7. Correct. So this is a method to find a perfect square. Now let's see another question. Final question of the day is: a particle moving in a circle of radius r with a uniform speed takes a time capital T to complete one revolution. So there is a circle of a radius capital R, and to complete one circle it is taking time t. So velocity is equals to this total distance by total time. So to complete one circle, how much distance it will travel? The circumference, which is 2 pi r distance it traveled in how much time? Capital T time. In capital T time. So velocity, the tangential velocity, we have the tangential speed is equals to 2 pi r by t. Now if this particle were projected with the same speed at an angle theta, now with the same velocity we are projecting a particle at an angle theta. So what will happen? A projectile motion will happen. Correct? At an angle theta to the horizontal. The maximum height attained by it is equals to 4r. Means our h max is equals to 4r. The angle theta, this angle theta will be equals to. So how we'll calculate this? Let's see. So we know that formula for h max. H max formula is equals to u square sine square theta by 2g. Correct? Now let's replace everything. So h max is given as 4r. Velocity, this v velocity we have calculated as 2 pi r by t, and its square will become 4 pi square r square by t square. So u square we have kept. Now multiply by sine square theta, and divided by 2g, Now 4 and 4 will cancel out, r and r will cancel out. So sine square theta, see from here, sine square theta is equals to 2g t square this 2gt square will go on the other side, so 2gt square, and this thing will go on the denominator, divided by pi square r, correct, divided by pi square r. Everything done? Yes, everything done. So sin theta will be equals to 2gt square divided by pi square r to the power 1 by 2, or we can say that theta will be equals to sin inverse 2gt square divided by pi square r to the power 1 by 2. So any option can we see? Sin inverse 2gt square divided by pi square r to the power 1 by 2. So our D option is the correct option. Okay, so this is all for today. I will be back soon with another video. I will be back soon. Till then, keep practicing. This is Anmol Yadav from Sri Gurukula signing off.